Here is the question from the ppm solution. Now it is saying that in the question, the molecular weight of DDT, DDT is a chemical, and that chemical is used as a pesticide to kill the pests and all the different insects. So DDT is 354 gram. The quantity of DDT required to prepare 1 liter of 10 ppm solution. Options are 10 milligram, 55 milligram, 354 milligram, 354 microgram. What is DDT? DDT as a chemical, as I have told you, the detailed structure of DDT and the composition of DDT, how it is created, how harmful it is, what is the effect that we will see very detailed in the water pollution chapter. For now, in this understand that it is dichloro, diphenyl, or phenyl you can say, trichloroethane. So, two chlorines are there. Two chlorines are attached with one carbon, and this one carbon is having another two valence you can see here, which is attached with the two phenyl groups, because this is dichloro and diphenyl. I can create one chlorine in the opposite side as well, like this. This chlorine, and this is attached with one phenyl group, or you can say benzene group. Two benzene groups are created here. Again, in which multiple number of carbons there have. So it is dichloro, diphenyl, these phenyls are attached with this, and again trichloro. Actually, trichloro means there are three chlorines here. Two of the phenyl groups are here, and in these phenyl groups, dichloro, two chlorines are again attached. See in very detail in the water chapter, water unit as well. For now, we just understand the chemistry here. Forget about the DDT. This is 354 gram of the DDT. But understand that in the ppm calculation, parts per million calculation, there is no need of the molecular weight. We haven't seen the molecular weight is being used in the formula of ppm, formula of ppb, or formula of percentage. The ppm, ppb percentage all are totally free from the molecular weight. It is not having any relation with the molecular weight. You have to just calculate the parts present. That's all is required here. So forget about the molecular weight. There is no use of that. Solve this. ppm is equals to, we know that in 1 ppm, 1 milligram is required to create 1 liter solution. Here 1 liter is right, so there is no need to change this 1 liter. You have to create 10 ppm. 10 ppm means 10 milligram would be required. And because in 1 ppm, 1 milligram is required. In 10 ppm, 10 milligram of DDT would be required. So, with respective, it is DDT, it is sugar, it is glucose, or it is salt, or any OH, whatever you are having. The 10 milligram of that amount of that particular solute, if it is dissolved in 1 liter, that would be equals to how much ppm? That would be equals to 10 ppm of that solution. So your answer here would be 10 milligram per liter of DDT. A is the right answer. So this is how you can calculate ppm or percentage. So like we are creating the DDT structure, one carbon, three chlorine, because this is trichloro, and because this is ethane, so another carbon would be attached to this carbon. Now this carbon is attached to two phenyl groups, and these phenyl groups are also having chlorine attached to them, because dichloro, diphenyl, trichloro for these two chlorines, and one chlorine are attached with these phenyl groups. These are creating two more chlorine. So trichloro, diphenyl, trichloro, and two carbons are there out of the phenyl box. That would be ethane. Now, the effect of biomagnification of this particular ethane we will see on that. So let's move ahead. Quantity of glucose required to prepare 1000 ml of 5% solution S. So 1000 ml of 5% solution, quantity of glucose required you have to calculate. This is percentage, and we know that what is percentage? Percentage is per 100. So 1000 ml you have to create it. So if there is 1 ml, one part will be required in 1000 ml. 1000 part will be required. 1000 multiplied by this is 5%. So 5 multiplied by 100. So basically, what you have to do, you have to calculate just 5% of the 1000. So 5% of 1000 is 50 grams. So 50 gram of the solute would be required to create 5% solution of glucose. So very easy question. This one. These all questions are already asked question in the exam. These questions are not created by me. Okay. Another question you can see here, the quantity of 0.2% solution needed to prepare 1000 ml of 10 ppm solution. So 0.2% is the solution concentration. You can see quantity you have to calculate of the solute. How you can create 0.2% solution of 10 ppm and 1000 ml. So basically, this is question from conversion of ppm to percentage, percentage to ppm. So for that, there is a special formula that we use always in these scenarios. That is N1 V1 is equals to N2 V2. What is the basic meaning of this particular question? Let's understand that. You have one solution, and you know the concentration of solution. The concentration of the solution is 0.2%. Okay. Now, your instructor is saying that take another beaker, and because we don't have the solute, whatever solution you are having of that solute, you don't have that solute, but you needed that particular solution for any experiment. And you need how much? You need 10 ppm. Your instructor will say, take this 0.2% solution and add a little water in it and create 10 ppm solution. So you will take some amount of this 0.2% solution and you will add more water in it, because we know that ppm is a smaller unit. The concentration is very high here. You are going to the lower concentration. You have to add water. So basically, this question is asking how much water or solution is required. My example is water, but basically solution, whatever solution it is. How much solution we have to add in this 0.2% amount of solution to create it equal to 10 ppm of how much? 1000 ml or 1 liter. So we use N1, V1 is equals to N2. Now N is the unit here. It can be normality, it can be molarity, it can be molarity, or it can be ppm or percentage as well. But the both units should be equal. If you are taking N1 as normality, you cannot take N2 as molarity. N2 should be normality also of that solution. If N1 you are taking in percentage, so N2 should be also in percentage. If you are taking N1 as ppm, N2 should be also in ppm. So you have to equal them, both N1 and N2. So either convert this 0.2% into ppm, that you can do, or you can also convert this 10 ppm into percentage. That would be also okay, no problem with that. V1 and V2 are volume of the solution. You can take again any unit, milliliter, liter, but units should be same. Don't take V1 as milliliter, V2 as liter, or V1 as liter, V2 as milliliter. No, that is not true. You have to take units equal every time. So here one solution I am providing, that you can convert this percent to ppm, or you can convert this percentage to ppm. That is up to you. But another shortcut I have, or this conversion thing, you can just skip by whatever they are, just divide it by them. You will convert it into unity. Like this percentage divided by the percent, it means 400. Now it is converted into unit. This is ppm divided by the 10 lakh, 10 to the power 6. That is again converted into unit. So I can divide the both values with their respective unit, and now they are converted into unit value. So now both are equal. So I have used here in this formula that N1 0.2 percentage, it means divided by 100 multiplied by V1. N2 is 10 ppm, 10 divided by 10 lakhs or 1 million. It is also converted into unit. And now V2 volume we know how much amount of or how much amount of this new solution we want to create. We know that is the 1000 ml. 1000 ml I am putting. Now I have to put the value of V2 in ml. It means I will get the value of V1 in ml. So because every time the both sides units are equal. So here V1 is equals to this 100 and 0.2 will go on the other side, and this would be changed position now. 100 would be numerator now, and 0.2 would be denominator now. This this is cancelled now. 3 zeros and another 0 for this 10. So this is only 100 is left in the denominator. And this 100 will go on the upside. So this is 100 divided by 0.2 will go to the downside, 0.2. And this 100 is left here multiplied by 100. 100 and 100 cancel. 1 divided by 0.2. Or you can take direct 1 divided by 0.2 is how much? It is equals to 5. So 5 ml. It means that if I take 5 ml of 0.2% solution, and if I dissolve this 5 ml 0.2% solution in 100 liter volume of the solution or that water, whatever you are having, the new concentration you will have of this new solution is 10 ppm. So this particular concept is used very widely in all the laboratories, especially chemical laboratories. If you are working in any chemical, generally we don't have the solute in pure form, and we need the solutions to convert it into one unit to another unit, percentage to ppm, ppm to percentage. Sometimes you will have 100 ppm solution, you want to get 10 ppm. So this N1 V1 is equals to N2 V2 formula is very widely used, and you can convert any unit of amount to any other unit of amount very easily with the help of N1 V1 is equals to N2 V2. Another thing you can do by your solution as I have told you, convert this 0.2% into ppm. So 0.2% to ppm. ppm is a smaller unit, so the value of this 0.2 will go high. So 0.2 multiplied by 10 to the power 4. Now it is converted into ppm. Now don't convert this ppm now. You can put this formula, this particular value directly in the formula, and in the place of ppm, just put 10. Or you can also convert this 10 ppm into percentage as well. Percentage is a larger unit, so this time you have to divide 10 to the power 4. You can put this value by you are taking 0.2% value in the formula. So that also you can do, either convert both into unity and then solve it. It's up to you how you want to solve it. But this particular method, if you are not understanding anything, go with this particular method. Divide with their respective value. And percentage divided by the 100 and ppm divided by the 10 lakh. So this is how you can convert. Another question. This time the question is from the titration. Again, a question from the past year's paper. In a titration, a 20 ml of aqueous HCl solution needs 10 ml of NaOH solution, 0.1 normal, for complete neutralization. You have to calculate the concentration of HCl solution. Options are 0.2 normal, 0.002 normal, 0.05 normal, 0.005 normal. Now understand the basic concept of what this particular thing is saying. Here is a HCl solution, right? HCl solution is what? HCl solution is acid. And we have NaOH solution. NaOH solution is what? Is a base. So they will neutralize each other. So if you take same concentration of NaOH, if you take same concentration of HCl and you mix them, so this HCl will neutralize the basic power of NaOH, the NaOH will neutralize the basic acidic power of this HCl, and both would be completely neutralized. Now the new solution would be not basic and it is not acidic as well. The same thing as it is acidic. The 20 ml of HCl solution we have, and it is neutralized, fully neutralized with the help of 10 ml of NaOH solution of 0.1 normal. So now you have to calculate the normality of HCl solution. The same formula you can use here, N1 V1 is equals to N2 V2. because both are if equal, then only they are going to neutralize completely each other. So here V2 is provided. V2 is how much? 10 ml of NaOH. N2 is provided to you how much? This is zero point 0.1 normal. Now 20 ml of HCl solution. It means the V1 is also provided. Now you have to just calculate this N1 and your problem is solved now. This is how much? 20 ml. And you can see that the unit of volume are equal here, ml, ml. And the answer you will get of N1 that would be in what? In normal, because you are taking N2 in normality. So this N1 is equals to N2 V2, that is zero point 0.1 multiplied by 10 divided by this V1. V1 go to the other side in denominator. So that is divided by 20. So this is 10 multiplied by 2 times. So N1 here is equals to 0.1 divided by 2. So 0.1 divided by 2, I can also write it like 10 multiplied by 10 to the power minus 1, not minus 1, this is actually minus 2. Why? Because two values I have provided here, two zeros I have provided here. Let's understand with more ease. What I can do, I can 0.1 multiplied by 100 multiplied by 10 to the power minus 2. 10 to the power minus 2, why? Not divided by 100. So 100 by 100 I have multiplied, for example. So this 100 multiplied by 1 is equals to how much? This 2 is 2. That is equals to 10. 10 divided by 2 and 10 to the power minus 2. So this is 5 times. So 5 multiplied by 10 to the power minus 2 or 0.05 normal. Two zeros, so two zeros after the decimal. 2 units after the decimal. Right answer here would be this. So this N1 V1 and 2 is very useful formula in this chemistry chapter as well as in the practical lab. Always remember it. If you want to create any solution, easily you can create by applying this formula. The solution is also provided here in the PPT itself, and when you can PPT the same thing, 20 ml, 0.1 normal, 10 ml, 1 divided by 10, 20 you can do here. So that is equals to, so 0.1 multiplied by 10 is equals to 1.